Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests, and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Hello, and welcome to FYI, the For Your Innovation podcast. I'm Brett Winton, the host and chief futurist at ARC Invest. I'm also on the Venture Investment Committee. Alongside me today, we have Charlie Roberts, also on the Venture Investment Committee. Charlie, hello, how are you?
Hello, Brett.
Charlie, we had a great conversation with Andrew Ng. Can you introduce us to Andrew? Like, why is he important and what are his roles in the AI space over time?
Absolutely. So thanks, Brett. So Andrew's an incredible teacher and founder, co-founder of several organizations in the space. So he was a professor at Stanford, built out a lot of really first principles machine learning and realized how that really helped learners accelerate and be able to innovate. He co-founded Coursera and taught many of the most popular courses on there, which have really been a huge unlock for many learners into their own new careers in AI and data science. He was co-founder and head of Google Brain. He was former chief scientist at Baidu also. And then also he co-founded the AI Fund, which is an incubator accelerator very focused on AI and especially working with large corporates. And as such has co-founded companies under that umbrella like Landing AI, which works with large companies to troubleshoot and figure out a huge number of solutions to their problems. So he's relevant to both really the public or the private and ultimately probably the public markets, as well as being a phenomenal AI educator.
Yeah, what I really appreciated talking to him is he has such like tangible experience with people trying to practically deploy artificial intelligence systems in corporations. What did you learn from our conversation that was like your most surprising takeaway?
I think probably for me, the two big takeaways. One were how comfortable Andrew is that agentic systems really are making great progress. And I think we didn't maybe press him on exactly which year he expects or how far out he expects sort of AGI. And there's probably as many different definitions of AGI as there are AGIs that don't yet exist to explain them to us. But certainly agentic systems, he seemed very confident that these were really here and now and coming without a ton of sort of technical risk to deliver. It was more of an execution. So that was interesting. And that somewhat accords with recent conversations I've had, but with others, but very recently. So that seems to almost be a turn quite recently in the last year or less. And then the other thing is quite how strongly he felt about open source, which is, I think, directionally where I had landed with him and believed where he landed. But he was very, very articulate and very sort of forceful in that opinion about the objections to open source on the basis of safety were really driven by lobbying groups and maybe were even tending towards disingenuous rather than actually, one thing we didn't really have time necessarily to press on too much, but it would have been interesting to expand that conversation, is whether there are actually any areas that he sees that there is a real safety risk, whether it's biosecurity or just something else. It sounded like not from the way he was putting it, but it would have been an interesting one to double click on and see if there are any exceptions to that sense. I think he made a very interesting point, though, that if you say that one of the big safety concerns with open source is, well, it's enabling bad actors with a hugely valuable and time-consuming resource like $100 million training run, and you're enabling them and therefore creating this asymmetric issue with, say, a terrorist organization. I mean, given what he said, and actually building off some of the research that you and Frank Downing and Joseph and others internally in the team have led, looking at the cost declines that we're seeing with training, he makes a very good point. If those cost declines continue and continue to just shave away, well, actually, maybe you're not leveling the playing field so much. Like maybe the training cost of, I think, nearly 200 million for Gemini, all told, starts to pale into insignificance after many, many years of compound reduction in training. So essentially, maybe even that last bastion of rationale for why making these large open source models is more dangerous, it does fall away. And I think he made that point very well.
He brought up the example that people always say their system is so dangerous, and then a couple of years later, it becomes open source, and then there's no evident danger that spins off of it, and there's a lot of benefit that spins off of it, or the benefit that spins off is much higher than the potential danger. Like I remember GPT-2 was supposed to be too dangerous to release for a while. And now, like literally, you have more than GPT-2. You have GPT-3 class systems that you can probably run on a phone. And so for me, an interesting point he made is how the kind of like governor of the pace of adoption here and innovation is in part the ability to evaluate the output of the models, which to me suggests that actually owning distribution is more important. Because if, you can spin up a system very quickly, but you still have to figure out whether or not it works in all of the, think of the corner cases within driving that you're going to encounter. And so having access to like a big distribution footprint then enables you to do an automated eval of a system before you ship it, that if you don't have distribution, you don't have access to. And so though his position is that the kind of open source is probably very eroding of the competitive advantages of Anthropic and OpenAI, I wonder if they can have like a large enough commercialization footprint that it allows kind of like their systems to be evaluated more quickly than something that is like, kind of like distributed in a very fragmented fashion.
I think you make a great point about the distribution, because also, it ties into something Andrew said as well, around this need. One of the drivers of needing enormous compute is because one's constantly now running inference on LLMs, and they're much larger models that require a lot more compute just to run inference just in one direction. So it's the pairing of the distribution, but then the distribution being also a route to gathering more data, especially if one's doing something like active learning, where you're using the machine to design the experiment, to ask for the data, to then feed back into itself. So the distribution and the data generation and the distribution become very, very tightly coupled. And so that's where this, we hear a lot in Silicon Valley about network effects and flywheels and all this stuff. And a lot of times that's sort of marketing speak or looks great on a slide, but that would be a very real example of where that's, that has a very real effect, especially as you combine it with an agentic system, which is making end-to-end decision-making, potentially running these kind of active learning experiment and running through some privileged distribution channel, like using an example from our venture fund within X, where you can have text generation, as we're seeing with Grok, being tested live on people, and then essentially it's real life RLHF, essentially reinforcement learning from human feedback, because you are getting the real human feedback from real activity in the system, and that's being fed back in. So I think that sort of thing, begins to bring huge power, and I think that resonates with a lot of what Andrew was saying. One other thing I think that resonated with me that Andrew said is when they run a process of discovery with these large corporates and really trying to understand which problems need to be solved and how big those problems are, and what is the hammer, the AI hammer that might be addressed against that nail, is just how overwhelmed they are with use cases and places that AI might play a role, and really way more than they'd imagined in many cases. I think directionally what that supports is something we've been talking about a lot internally within ARC and various brainstorms. The kinds of companies that are best set up to have highly customizable approaches to AI, where the company can, it's more of a platform as a service than sort of point solution SaaS, essentially. And there's this high degree of customization wiring different parts of the potential with AI together to achieve a solution. One obvious example of that, well known, is Palantir, that I think really AI has turbocharged its ability to serve its customers, and we're really seeing the fruits of that kind of potential. I think actually it was from another podcast Andrew did at some point, saying, at most, if you look at any code stack, any GitHub repo or whatever from any large machine learning AI data science kind of a project, you're going to find the interesting modeling code is typically less than 5% of all the code, because most of it is just wiring essentially to bring, very, very important, but infrastructure, pulling data from one place to another, making sure that the libraries are all lined up. It's things like that. And a lot of just functions to drive everything else, and a lot of ML ops, what have you. But a very small amount actually of kind of modeling payload code, if you like. Now, what happens with a lot of these customizable solutions like what Palantir is building is that a lot of that just gets abstracted away and just taken away and taken off the table and replaced by something very reliable, which essentially where these pathways have been trammeled before and don't have to be built from scratch or maintained in a very specific high maintenance way. And I think it's becoming quite clear as these AI solutions get rolled out at scale that model looks advantageous to either the point solution, fixed SaaS solution, or even companies that are trying to go back the other way and have come from SaaS and are trying to make their solutions more customizable.
Yeah. It's kind of like you said it's turbocharging their business. Now, I think you could argue that there's actually kind of like investing in that infrastructure layer that sits underneath it is something that companies need to do in order to actually successfully deploy against kind of the possible solutions they have in the AI space. And so it both allows you to kind of like onboard solutions more quickly and frictionlessly, and to have them running and operating in a continuous way.
And I think another piece that arose from some of the points Andrew made, I thought was interesting. If we really are so close, and hearing someone who's quite conservative and very data-driven as he is, being so confident that we're going to see meaningful agentic solutions, it's kind of currently or very near term, and these are eminently possible with no technical risk, essentially, delivery risk, is also what happens then around, and this is whether this is B2C, B2B, within SaaS, within PaaS, all of these settings. The human as a decision maker, while potentially climbing higher up the stack and making maybe more consequential leverage decisions, is also being removed from quite a lot of what might be economically meaningful solutions at the moment, or decisions at the moment. And that might fundamentally change the go-to-market for a lot of SaaS providers, I suspect. Because a lot of what a human is currently being asked to just make choices on, or even an accounting department, may just be handed over. Essentially, the keys to that car get handed to agentic systems, and the systems which best provide the baton passing or the best handoff to other agentic systems are going to be the ones that increasingly win in the marketplace. And I think that's going to be a fundamental groundswell of change that maybe isn't fully appreciated or factored into long-range forecasts at this point.
Yeah, it's like you need to have your API SDK really well embedded by the model, because or else the model won't call on you when it needs a service. Do you know what I mean? And so kind of like the being trained into the model is the new appearing in organic Google search in terms of like being lifted in a B2B sense,
Exactly. If the agentic model is the bee looking to pollinate and make decisions, that flower better look very juicy and attractive, and for that API, and exactly so. And I don't think we know yet what that looks like and just what that does to existing world orders, but one might imagine it could be very disruptive to some.
Yeah. So everybody, I hope you enjoy the interview. Just to give you a high level sense of how big we think the market opportunity is here. We think that AI software is going to be a $13 trillion top line revenue market by 2030. Compare that to total IT spend today, around $4 to $5 trillion. So there's a reason that we are intensely interested in this, and it's because we think there's an obscene amount of business value that's going to be created on the back of these AI systems. And so it's great to be able to talk to somebody who is working with the businesses trying to create this value and has such a kind of like storied, long, lived history of building AI systems and seeing both the promise and the pitfalls of trying to do so. So enjoy the interview. Thanks for joining.
Hello, Andrew. Welcome to the ARC for Your Innovation podcast. Winton, ARC's chief futurist, and we're very excited about the discussion. Andrew has been one of the most impactful researchers and educators, critically, within and across artificial intelligence. The number of high-profile roles, such as one of the co-founders and leaders of Google Brain, chief scientist at Baidu, co-founder of Coursera, and taught many of the most popular courses on Coursera, as well as co-founder of the AI Fund and Landing AI and several other companies where he holds board roles. Andrew, I think, though, my favorite of the stats about your delivery to the whole community has been, I think you told me most recently, that as many as 1 in 1,000 people in the world have taken one of your AI courses, which is just such a huge contribution to the whole community and the ecosystem, and what an inspiration. So excited to get into the discussion with you about myriad AI topics and beyond.
Thanks, Charles. Great to see you and Brett here.
Great. I think maybe you could start out, Andrew, and lay out your view of where we are and call it like the AI journey. I think there's a lot of discourse out there, and actually there has been for some time. AI is hitting a wall, or we're achieving performance advances that aren't going to yield actual productivity. And where do you think we are in terms of AI capability and the trajectory forward of AI capability? And how do you assess that?
For the last 10, 15 years, there've constantly been a small number of voices saying AI is hitting a wall. I think that last statements to that effect were all over and over proven to be wrong. I think we're so far from hitting a wall, and I'm surprised that anyone even seriously say that at this moment in time. AI technology, which is a general purpose technology, has advanced so much, and there are advances that are just breaking now, or even in the near-term horizon, that the set of tasks we could do with AI is just growing rapidly. At this moment in time, a lot of attention on generative AI and large language models. The set of tasks we can get them to do, frankly, significantly surpasses what's actually been deployed so far. And it's actually very clear that more inference capabilities, more GPUs or other types of hardware is a bottleneck to just getting a lot more AI out in the world. And this is a problem that we know will be solved. There are very strong financial motivations to solve the supply chain, be it GPUs or other types of hardware. So even if AI stopped inventing any new tech, which, there will be a lot more deployments in AI in the next few years. And of course, the even better news is there are also new tech on the horizon that's stacking on top more and more S-curves that drive even more applications in the future.
Yeah, so just to synthesize, you're saying the capability we have now actually hasn't really been deployed into the commercial marketplace yet. So just doing that will result in a lot of productivity advance. And then there's kind of like under the hood architectural improvements that should deliver even more capability advances. Is that the right way to think about it?
Yeah, and in fact, I routinely talk to people that have ideas, maybe even prototype, for driving significant ROI for AI, but for whatever reason, they just don't have enough GPUs yet, or token costs are still a little bit too high, or they just haven't a software engineer with the bandwidth to go implement this thing. It's not yet done. So there are already, I think, a lot of good, I would say, pretty validated ideas that drive significant ROI that for, frankly, whatever capacity types of reasons that will absolutely get solved in the next 1 or 2 years have not yet been deployed. So this is why I'm 100% confident there will be a lot more valuable AI projects. It's because the bottleneck to getting them deployed is stuff like, GPU supply chain, right? And so those GPUs will get made and more projects will get deployed. And I think as an example of upcoming technology, I'm really excited about AI agents, or we call them agentic workflows, which is this idea that the way a lot of us use LLMs today is you prompt it and it spits out an output. And that's a bit like asking an AI, or maybe think of asking a human person to say, hey, I want you to write an essay for me on a given topic, but I need you to type from start to finish in one go without using backspace. And, while people can write like that, we don't do our best writing that way. Instead, we do our best thinking and writing with a more iterative workflow where you write an outline, edit the outline, write the first draft, critique it, do some web research. And it's a much more iterative process that lets us as people deliver a better work product. And agentic workflows or AI agent workflows do this as well. And we're already seeing massive improvements in the accuracy of a lot of AI applications with agentic workflows. And again, one of the bottlenecks to agentic workflows is we just need faster inference capabilities to deliver this, because you need to call an LLM over and over as it iterates on the work product over and over. But again, so many people are working on it. I'm just very confident that as the supply chain gets better, as better chips come online for AI, not just AI training, but AI inference, a lot more of these workloads will be unleashed. By the way, I was actually very influenced by the ARC report on where you estimated that training prices are falling 75% per year, and inference prices maybe 86% per year. I don't know if those exact numbers will turn out to be right, but I definitely see prices falling rapidly, and I think it's fantastic that further innovation that this falling training and inference costs will in turn enable.
Yeah, I mean, for us, the general idea is you not only have that cost decline, you also have investment dollars pushing into it. So you compound the cost decline with the investment dollars, and you end up with an expectation for 100 or 1,000x capability improvement over 2 or 3 years. And so I think, do you ascribe to the belief, like Jan LeCun would say, well, you start out with a system that has an error rate over time, and even a agentic system, and that error rate compounds. So actually, the longer the workflow you're working on, the productivity collapses because it's a compounding error. Like, do you think on the current architecture that is overcomable, or do we need more architectures for agentic workflows to really work consistently?
So the compounding arguments that, if you do 5 things or 10 things or 100 things, you need them all to be right, that works for, very simple. I would say if you're doing an open loop workflow, then yes, you need every step to be perfect. But once you implement agentic workflows that can look at the steps and then fix its own errors, then I think the compounding problem is much better. So, one example, this is actually a surprise to me. I had coded up a very simple agent to do online research and then write a report. And I remember I was doing a demo to a group at Stanford where I was running a live demo. And for whatever reason, that time, the call to do the web search failed. I think it was a rate limiting error from the API I was using. And I was in front, I was like, oh, shoot, that was going to fail. But to my own surprise, the agent said, oh, web search failed. Let me use Wikipedia search instead. And I'd totally forgotten I gave it a web search tool and a Wikipedia search tool. And so to my genuine surprise, the agent, that I had coded up in Python was smart enough that when web search failed, it pivoted to Wikipedia search, and then the demo still completed successfully. And so with agentic workflows, they're not magical. They make mistakes. They're highly flawed. But when you have agentic workflows, you can fail on a step and then look back and say, what happened? Critique his own work and then go fix it. It makes them much more robust. And I don't want to overplay the analogy to AI and humans. They're very different, but just like humans, hey, when we do stuff, a lot of things don't work that first time, but our ability to reflect, critique, and fix it, that makes humans much more robust at execution tasks. And I've seen AI agents able to do some of that too.
Do you think, Andrew, that there needs to be another step change architectural improvement, like of the scale of a transformer, to get to true agenticity, or is maybe the effective marriage of something like LLMs, obviously, probably, plus reinforcement learning, maybe, and plus or minus diffusion or other things that already exist in the toolbox with sufficient scale? It sounds like you feel maybe that gets us there.
I think agentic workflows are working just fine on transformer neural networks. So, I know that there's exciting research on Member, SSRM, so other alternative models to transformer that look promising and worthy of further investigation and testing. But I don't think it'd be great to have better models than the transformer. I don't think we absolutely need them, but that'd be nice to have. One thing I think is really underestimated is the importance of fast inference and fast token generation. I think what's happened until recently was a lot of large companies were spending, massive budgets on buying GPUs for training. And it's been great. It gave us large foundation models, both proprietary and open source ones. But I find that the ability to do inference really quickly is becoming more of a bottleneck to a lot of applications. So when Meta released the Llama 3 70 billion, that's a really fantastic open model. And if we could do inference on that 10 times faster, we can get these agentic workloads running much faster. Because if you're using, ChatGPT or Claude or Gemini or whatever, as a human, humans read maybe 6 tokens per second, plus minus. So why do you need to generate much more than 6 tokens per second? If you generate 10 tokens per second, faster than I can read, so you don't need to go faster. But with agentic workloads, an AI might write a draft, critique it, fix it, and so you generate lots of tokens. The AI is doing lots and lots of work before a human ever looks at it. So I have some teams that are doing agentic workloads that might take like 25 minutes of work, before it finishes its output for a human. And you can crush that, say 25 minutes of processing down to 2 minutes of processing. That's a game changer. It significantly changes the customer experience to get a result in 2 minutes or 1 minute instead of like 20 or 25 minutes. So that's why I think so far more work on really fast token generation, fast token generation. I think that would really help this next wave of AI, in addition to continued investment in training, which obviously is very important as well.
The two are co-related, right? As in, one of the, I think, really interesting dynamics in cost declines in AI on inference is if I throw more training dollars at a system, this is what Meta is doing, you can compress like more information into a smaller parameter model that then could be run both more quickly and more cheaply. Like, so you reduce latency and you reduce the cost to infer. And so you're getting kind of like this double, you're getting performance advance and cost decline at the same time. And so that's like I think an interesting dynamic here. And it's a function of how much money you're throwing into the training compute.
I would say all that helps. And also, even if you take a large model, so for a lot of the, commercial website type, large Gen AI providers, maybe they generate, order of magnitude, ballpark, let's say 10 tokens per second, right? So faster than I can read. I probably read, most people read maybe 6 tokens per second. So generate, 6, 10, 15 tokens per second ballpark. There are now companies, Grok, GROQ, as one example, that is generating 300 tokens per second. It's not apples to apples. The models are different, but I think we can generate. And then Samba Nova also has a demo generating many hundreds of tokens per second. And I find these, and there are other semiconductor makers, that quite a few of them, more than one or two, that have shared with me privately that they're also working on cheap, super fast token generation. So there are a lot of companies working on this, and I think this will unlock a lot of new capabilities. And this super fast token generation, I think of super fast token generators, let's say north of 100 tokens per second for the large model, like a 70 billion parameter version of Llama 3. And that lets you do really sophisticated things. And I'm actually excited to see more semiconductor makers taking inference more seriously. The other funny thing I've seen is there are these large companies. I've actually heard this from again, multiple people at this point, but there are large companies that completely appropriately had invested in GPU infrastructure for training. And then you have this fantastic GPU team that's built this wonderful training infrastructure. And it's really tempting for that team to say, oh, we have the best infrastructure. We'll build the inference infrastructure as well. Because that team kind of did a great job on the training infra, so they then go and do the inference infra. But to me, the questions I'm trying to think through is, how much does it make sense? I'm actually hearing this from a lot of businesses now. How much does it make sense for the training and the inference infrastructure to be the same infrastructure, or are there enough differences, that really new architectures, right? Hardware as well, as well as clearly software is quite clear, but also what are the hardwares we should contemplate for inference infrastructure?
Well, certainly, like if you're at the endpoint device, it has to be different, right? If I'm throwing a chip in a Tesla vehicle, like that's its own kind of stack. And you could argue, maybe like there's a lot of compelling reasons why some of it or a lot of it should shift into endpoint devices just from a consumer like utility perspective, I would think.
Yeah, that's true. I think on device is clear. And then even in the cloud, I think that there are actually enough differences in the training versus the inference workloads to work backward from there to the architecture or the software types of changes. In terms of on device endpoints, I think, yeah, that's totally, totally with you on that.
One of your biggest contributions, Andrew, just in terms of the teaching and something I think you've always been calling out is the need for people and developers, people learning to learn about ML ops in the context of machine learning as well as the research side. And I just wondered, is there a piece here? Do you see a future avenue within ML ops of actually orchestrating calls to the inference and even maybe training being done separately once the inference has been run? It sounds like that's almost where you're heading.
Yeah, it feels like, because so many LLM-based applications are so new, I think that the space of LLM ops is still quite new. And how do you build and deploy and maintain and so on a large language model? And it's interesting, the AI stack is changing a little bit, right? I think with the silicon, with the cloud providers, and then there's an interesting orchestration layer that's coming up. So tools like, Harrison Chase doing a great job on LangChain, or Jerry Liu doing a great job on Llama Index, is orchestration layer. And then there are also the applications built on top. And then another interesting thing coming up is the agentic framework, which is maybe another type of orchestration layer. So I think that, True AI, AutoGen, LangGraph, right, doing a great job building that multi-agent orchestration layer. So the AI stack itself is changing. But for us, and I spend most of my time with the application layer. I find that at AI Fund, there are so many opportunities at the application layer, whereas the foundation model layer is super competitive. And look at everyone pouring, I don't know, hundreds of millions or billions or maybe more than billions at some point of dollars into training models. So I think it's a fantastic sector. I'm sure some companies do really well, but it's so competitive. Whereas for the last, I don't know, long time now, I've focused more on the application layer, where I find that there's a very rich set of opportunities and it's not nearly so hyper competitive. In fact, at AI Fund, we seem to keep on working with corporate partners that bring to us compelling use cases. And we look around, it's like, there's like zero or maybe one competitor working on that. So there's so many opportunities in the application layer as well.
For those application layer type companies, how are they thinking about what they're plugging into Downstack, like at the foundation model? Are they saying, hey, GPT-4 works and it's on the shelf today and we use it, and potentially designing for being able to flex into another foundation model? Are they like fine-tuning a Llama build? Like what do you see as the strategy at that application layer and how that will play into the competitiveness at kind of lower down stack?
It's been rapidly changing. I think that for a lot of projects, the majority of projects is still, there's just a funnel, right? A POC to production and so on. So as is the case for most things in life, there are more projects in POC than in production. This is not a bad sign. That's just life, even for mature technologies. But I think for the projects in the POC proof of concept stage, many teams are starting off using GPT-4. And then I think Cloud 3 is becoming, Cloud 3 Opus has become really competitive as well. And then just in the past few weeks, even Llama 3, has become competitive. And obviously, many teams have a Google orientation, and some will use Gemini 1.5 Pro. So, but I would say, I hear teams using GPT-4 the most by a large margin at this point in time. And then it turns out that one of the bottlenecks to faster growth of the sector is evals. I think one of the wonderful things about Gen AI is the cost of development is so much lower than it used to be before. Right? You can build compelling applications in like a day. But what I'm seeing for a lot of projects is you can build a compelling prototype in a day, but to collect data and evaluate it properly, that might take, let's say 10 days, like let's say 10 times as long. And it's just not fun, right? If it takes me a day to build something, now I got to spend 10 days to evaluate it, or maybe it takes me a week to build something. but now it's going to take me like 2 months to evaluate it. So I think there's a dearth of evals or evaluations in AI. And this has actually been a factor to make people reluctant to switch models because, if you start with maybe GPT-4, if you can't evaluate other models, you kind of stay with what you started with. But I'm seeing a lot of momentum on building better evals to let people kind of more efficiently suss out of these different models. Is the performance pretty much indistinguishable? In which case, I might want to go to the lowest cost provider. And there are definitely companies, right, spending many, many millions of dollars on tokens that have ramped. And so cost savings to tokens are significant. But then there are also companies spending, $10 a month or whatever for the POC, and like they're less motivated to do a lot of work to switch to the lower cost provider. But once it ramps, then I think having better evals, which lots of people are working on. Actually, in my, the small amounts of spare time on weekends, again, evals is actually one of the topics I think about. I think having better evals will make it much more efficient for people to evaluate multiple models and then use the most appropriate one from a price performance trade-off and speed trade-off for their job. So a lot of progress there.
We're excited to hear that Claude is doing well, and we were that was one of the earliest investments we made from the ARC Venture Fund was Anthropic, and we've stayed close to the company, very excited about the prospects, as well as more broadly, obviously, the GPT family of models and things, and lots of the open source as well. It would actually be very interesting to hear, Andrew, your thoughts on the current debate about open source, pros, cons, risks, opportunities. Obviously, it's become an almost polarizing discussion actually at some level, which is, I think, I've almost never seen as many very, very informed, very passionate people have as polarized views within data science and machine learning as on this particular topic right now. So it'd be interesting to see where you feel that you're landing on the discussion and debate and how that's changing through time.
I think open source is great, and we should do everything we can to promote it. I think it'll make the world and make so many people better off with more open source. It's been interesting. I was really surprised last year at the intensity of the lobbying efforts to shut down open source, which would crush, frankly, it crushed American innovation and crush global innovation. But as you can imagine, there were a small number of players that, if you've invested billions of dollars to train large foundation models, it's kind of annoying if someone else open sources it and diffuses the value of that very expensive investments. But so boy, there was such intense lobbying efforts. At the start, the lobbying efforts were based on AI could take over and kill us all. I was just in Washington, D.C., and speaking with various legislators, the AI could kill us all. That's lost credibility. But the lobbyists, they're smart. They don't give up. It shifted from AI will take over and kill us all to AI could create bioweapons. And then I think that since then, there have been enough reports showing that, spreadsheets can be used to create bioweapons, but we're not freaked out about, spreadsheets. And AI doesn't seem that helpful for creating bioweapons. I think actually OpenAI released a report showing basically not much case to showing that, AI doesn't seem, the fears of AI bioweapon don't seem to be what the certain people were trying to make it out to be. So I think the bioweapon argument has lost substantial credibility. But the lobbyists don't give up. The latest argument is national security. If we open source our near-peer competitors, we'll get access to it. So I find it fascinating, the intensity of the lobbying and candidly, the willingness to shift arguments every few months to keep on pushing their shut down open source agenda. And maybe I would have overly high hopes for intellectual honesty from some of these lobbyists. And I think, I will just tell you what I think of this. I think that, one interesting thing I've seen is open source is clearly a supply chain of the global AI stack. And I find that technology tends to reflect a nation's or the developer's value. So for example, many countries use Google Docs. And if you look at Google Docs, it's actually really easy to share Google Docs, and it's pretty difficult to lock down stuff. You can lock stuff down. That's enterprise grade things, but Google Docs was a reflection in my personal view of Google's internally very open culture. And if you look at, say, iMessages, the fact that it's end-to-end encrypted, that's a reflection of a value that says we value privacy. Whereas there are definitely other nations that would not, want to develop end-to-end messaging apps because maybe reflecting a different set of values that maybe, government should be able to look at communications in the name of some sort of maintaining the peace or something, right? Different than the values that I think many American companies would aspire to. And I think it'll be like that for LLMs. If we don't participate if the democratic nations don't participate in the supply chain of AI, then other nations will. And what this means is when someone in some other country asks an LLM, what do you think of democracy? Is it good or bad? I would quite like an LLM to reflect democratic values, but I think this is why I think the attempt to shut down open source is actually very dangerous. It's not only bad for innovation, which clearly would be awful for innovation, it would even be not in US or UK or European Union interests. Actually, I've been really surprised at how effective the lobbyists have been in convincing a whole bunch of European legislators to legislate very clearly against European interests.
I mean, leaving aside the kind of regulatory pressure on open source, do you think in a future state, do you imagine that basically Meta's efforts to throw literally tens of billions of dollars at training these models and then releasing them into the wild for they have their own corporate strategy behind it. But, do you think that effort is sufficiently degrading to the economics of kind of like the closed LLM foundation model type players that actually kind of like that part of the value chain is not going to accrue a lot of profit over time at all, that it's like really endangering to the OpenAI and the Anthropics of the world in terms of their ability to ultimately generate commercial profitability off their franchises?
Yeah, at this moment in time, the pure foundation model layer, I think there are challenges. In fact, from your own report about cost falling like 75% per year, that makes it really difficult to build a moat, right? Isn't it annoying if you spend $100 million training a model and a year later, competitors could do it for $25 million and a year later, another quarter of that. So where is the moat? But I think there are moats that are not just a pure foundation model layer, but other layers. It may also end up being a little bit different for consumer. But today, it turns out that, and I think as you well know, switching costs for LLMs is actually really low. Maybe there's a little bit of work needed to rewrite the prompt, but not that much. But we'll see how this evolves. I think there could be other technology components, that increase the strength of the moat. But if it's just a foundation model and nothing else, that core piece, as important as it is, I don't know how strong that moat is.
But do you think that part of the reason that Meta's been able to push into the space is up until kind of call it ChatGPT, or it really became apparent to everybody that there was a lot of commercialization opportunity here. The teams were happily publishing what they were doing. They're like, this is our recipe. This is how we built it. There was an ethos of, even though the models were closed, they're closed for safety reasons. And they were sharing essentially, this is the architecture and the way we're going about it. With GPT-4 forward, now everybody's like, well, I'm not showing my cards now. So isn't there more opportunity for essentially performance differentiation across the teams because the recipe is no longer commonly shared?
I think there's enough flow of talent among the different companies and enough flow of ideas. I think it's quite challenging to keep recipes secret for very, very long. Maybe keep it secret for a little bit of time. And I've seen these talent battles as well when big tech, going after ads business or clouds business. I've seen these, you definitely get a short-term proprietary tech advantage, but the long-term advantage, and I don't know if this piece is that defensible. And I want to say, and I think Meta releasing Llama 3, it's been interesting. You mentioned people keeping things close in the name of safety. For a long time in AI, if you look back, maybe over even the last 10 years of history, almost every time someone says, my tech is so dangerous, I got to keep it close, When usually, year or two later, someone open source something similar, far more good than harm was created. I'm not saying no harm was created because there are bad actors that do use open source, but it's so clear that every time someone said, my tech is so dangerous, maybe a year or two later, there's an open version. When it's open, so much more good is created. So I feel like, and in the case of Llama 3, there's so many people building things on top of it. Like, for example, the original version of Llama 3 had limited context window length, but because it's open, there are now developers modifying Llama 3 to a very long input context length. They couldn't have done that if it was a closed model. So I think this type of open source innovation is really powerful. And the fact that we can now, provide us serving Llama 3 up very inexpensively per token. This open source is creating so much innovation. So yeah. Oh, and then as the Meta's releasing of Llama, I think when Meta released Llama, I saw people message say on social media, wow, what sort of 7-dimensional chess is Mark Zuckerberg playing? But I feel like the business case for Llama being released in open source, it seems, it doesn't seem super mysterious to me. And in fact, candidly, I saw Meta play a very similar move with PyTorch. Because, Meta, I think, not surprisingly, has been sensitive to needing to build on others' proprietary platforms. So when iOS changes its privacy rules or whatever, that impacts Meta's business because iOS is a proprietary platform. So years back, when my former team, when Google Brain was building up TensorFlow, I actually hired the guy, Rajat Mongar, fantastic leader that wound up leading TensorFlow. So Rajat and I still chat, fantastic engineer. But I think, when you worry that the dominant deep learning development platforms can be controlled by a competitor, proprietary, I think Meta, frankly, played this hand beautifully, not trying to own it, but creating open source PyTorch that then gained a lot of momentum and candidly probably diffused the risk of, someone else controlling the deep learning platform that everyone has to build on. And because Meta doesn't operate a large cloud business, I think it just needs the underlying platform to be free for it to build its business on top through the social network and communication and advertising. So I think that it was my friends and my former team that built TensorFlow. So it's really interesting watching Meta make that move with PyTorch. And I think now, from a business perspective, it's very rational. Why? It's in Meta's interest to make sure there's a open source foundation model and an ecosystem, because Meta can then build on top of that without worrying about, having to build on closed platform like iOS, as someone might change the rules on at some point. And because Meta doesn't operate a large cloud, there's less of an incentive to keep it proprietary to try to sell API calls. So it seems like a very rational business move. But also, just to be clear, it doesn't take away from my gratitude. And I think really gratitude that many of us in AI should have for Meta open sourcing, giving away this really valuable thing, even though there's also a very rational business move.
Do you think that for kind of the AI application companies, Sam Altman is out there saying, if you're designing for this level of capability that GPT-4 has, then you're actually making a huge mistake because we're going to be much more capable, sometime this year and next year. Do you anticipate the strategic landscape playing out where it's like OpenAI delivers a very meaningful advance, and then everybody else follows along, maybe 6 months in delay, and also at the AI application side, does that change the way in which you think about or approach kind of AI applications that are potentially kind of meaningful and commercializable because of the rate pace of the underlying technology?
Sam's a great leader. I've known him since he was an undergrad. He worked in my lab at Stanford way back. But OpenAI, I feel like one thing I really respect about OpenAI is it moves aggressively. It is very much I want to say, I don't know if OpenAI would use the term wartime operation, but OpenAI, I really respect the way that Sam and team are bold and make bets and place bets. And, when you do that, not necessarily every single bet will pay off, but you just need a few bets to pay off handsomely and you can deliver fantastic results. So OpenAI seems to do lots of different things. I don't want to speculate on all the things they're doing. I feel like training foundation models is important. I'm looking forward to when GPT-5 or whatever is released. I'm sure it'll be significantly more capable than GPT-4, but I'm also confident that there'll be a lot that GPT-5 cannot do, and that there'll be work for lots of other applications to be built on top of it. My team did a small study showing that GPT 3.5 for a coding problem, writing code, standard coding benchmark, GPT 3.5 of an agentic workflow actually outperforms GPT-4. So the movement from GPT 3.5 to 4 was very exciting, but that improvement was actually dwarfed by the improvement you get by using the agentic workflow, even on GPT 3.5. So I'm very optimistic that, GPT-5 or I have no inside info, so I'm making this up. Claude 4, or Gemini 2. I made those up. I have not inside info. I'm excited about whenever those come out, but I'm also confident, and I'm certainly bullish that other things, agentic workflows and other things built on top of even the current generation of models can get us very far on solving very valuable business tasks, very valuable applications tasks.
On that question, Andrew, actually, I think you've said over the years you're very interested in healthcare, and I believe you've got medics in the family and things. And I think there's an example in Mustafa Suleiman's book, The Coming Wave, about what his take of the modern Turing test, which I think his example he gives is, what would it look like if you could give an agentic system, say $100,000, and ask it to go and generate $1 million a year business on Amazon or something like that, which would require it to go and set up a company and write a marketing plan and begin to initiate that. Is there in the back of your mind, whether it's in health or somewhere else, a modern day Turing test that you'd love to see an agentic system get to in some near term?
I'll say, I feel like AI, artificial intelligence, is so different than human intelligence or biological intelligence. Both are really valuable. We keep on trying to benchmark AI to what humans can do, which is fine. No harm to that. But I think because human intelligence is so different, it's actually pretty difficult to AI to do everything a human can do. And certainly, let's try to make AI do that. Hopefully, we'll get there sometime within our lifetimes. But even prior to trying to match humans, there are already so many things AI could do, narrow tasks way better than any human alive can, that creates a lot of value. So I think I'm actually more focused on that step-by-step progression, which is progressing very rapidly, of the set of things we could do in AI in all sorts of industries, rather than trying to do this other thing, which is fine for researchers to do too, of trying to benchmark to humans via maybe modernized version of the Turing test.
I mean, it seems like the ultimate, like, benchmarks are useful insofar as they indicate some kind of commercial application that can then scale and become really tangible and real, right? And you're focused are very focused on like really practical like applications of like bringing AI to market. What do you think about outside? I think we're in some ways because the language is the interface with these models, we also like maybe over-index on language generation. Like you talk about rapidity of token generation. Well, in reading, like, yes, you can massively exceed my rate limit of taking in information, but in kind of like the visual field, like if I'm doing like diffusion models are still really, really slow relative to what I need. Like, how do you think about kind of like applications outside of language in robotics and autonomous taxi in kind of like the healthcare field, maybe? Like, where are you excited about kind of the rate pace of advance there? And do you think those are good areas to be looking at?
I think we're getting there. So the text revolution had come first with large language models, but I'm seeing the image processing revolution come a little bit later. And I don't mean just generation, but I mean analysis. So, one of the teams landing AI is doing a lot of work on large vision models. And I think that over the next very small number of years, we'll see a lot of progress in the ability of AI to analyze not just text, but analyze images. It feels like there are multiple fronts that AI is advancing rapidly. And then in terms of application sectors, AI fund we've actually tried to stay sector agnostic. So we decided our strategy is our swim lane is AI. We try to be experts in AI, make sure the AI tech is built well, and make sure we know what AI can and cannot do. But because AI is a general purpose technology that applies to healthcare, financial services, logistics, education, on and on and on, we can't simultaneously be expert in all or even any meaningful fraction of all the sectors to which we want to apply AI to. So the motion that we have at AI Fund is we really like working with corporate partners that have subject matter expertise to collaborate. And these are often LPs, but can be non-LPs as well. We often work with large corporations that have deep subject matter expertise in a sector. And with our expertise in AI and their expertise in a specific sector, we then come together to build something very unique. And so we do work in healthcare, for example. But in our most recent healthcare project, we're working with an overseas deep subject matter experts in a certain geography where they have deep market and go-to-market knowledge, in addition, which complemented with our technical knowledge, is letting us try to build something pretty unique in healthcare outside the United States because of a specific go-to-market and market that we felt might be easier to tackle first overseas. So I find that the opportunities are numerous. Here's one other fun fact. Every time we get together a large corporation and we do a brainstorm exercise, every single time, we end up with way more ideas than they or us or really anyone realistically has resources to implement. The number of ideas, promising ideas, seems to always delightfully and annoyingly vastly surpass the amount of resources any of us can use to build.
Are there things from your experience with AI Fund and speaking to large corporates and having a very deep understanding of how AI does and will apply, but I think you've also got a rare understanding for a very deeply technical person of the business case. Are there things that you think in the 5-year time frame, big problems that the market thinks will have been solved by AI that we still will have? And conversely, big problem, maybe one big problem that will have completely gone away because of AI that the market or people just generally don't realize?
I think it will take time. I know that it's tempting to say, I think it will take time to make a lot of these shifts in a lot of industries. It's been interesting. With the wave of deep learning AI, we're doing a lot of kind of industrial automation, repetitive tasks. And as we know, atoms are slow to move. And so when we're doing things that involve shifting the way atoms are configured in the world, we'll get there, but it tends to take a while. It turns out bits can also be surprisingly slow to move when it involves culture change, internal change management. But so we'll see how fast we can help many businesses rethink their workflow. But maybe optimistic that bits are faster than change than atoms. But it turns out that when you're changing bits, when there's a change management process needed, sometimes it still takes a couple of years. But so I think that we're definitely Gen AI is definitely transforming a lot of knowledge work, and I think every knowledge worker today can get a boost in efficiency by using Gen AI. So that's exciting, and with better tools that will set up the options to even grow bigger.
This was great, Andrew. Thank you so much for your time. We'll see you soon.
Yeah, thank you. It's always really fun to chat to you guys. You guys are so deep. And really, congrats on your research work. I think I really appreciate it. I really enjoy reading Ark's research work. So
we will keep it coming. Just please keep all the amazing education and work coming too. And we look forward to the continued collaboration. Thanks so much, Andrew.
Thanks, Charles. Thanks.
Thank you, Charlie. Thank you, Andrew. This has been FYI, the For Your Innovation podcast of Ark Invest. Please like and subscribe and rate us 5 stars. See you next week. This is Brett Winton, signing off.
Ark believes that the information presented is accurate and was obtained from sources that Ark believes to be reliable. However, Ark does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from Ark. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARK's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.